Hi, student people. I thought we'd start doing some stuff on prediction. I'll do it here and then we'll go through it again in class, but at least you'll have a look at it. Okay, let's go back to the car library that we took a look at the other day on our movie. And let's attach the uh, Canadian population data set, or I'm sorry, my fault, the data frame again. And what we're going to do, let's look at it. Excuse me. And it is 26 observation of two variables. So we have the year, that's our x variable, and our y is the population. Okay. And what I want to do is predict. And I know, because I know, that the last x value is 2001. So what I would like to do is predict for 2011, because these are in increments of 10. All right, so what do I need to know? Well, there's a predict command, and it's really predict. We're just going to use predict, but I want to show you this predict LM because that's has the special pieces that we're looking at. Okay, let me puff this up a little bit. So we're going to have our object. That's our LM object that we fit the other day. New data is a data frame. So we're going to create a data frame of our x's. Then we need to decide what kind of interval we want, if we want any. We'll talk about that more in a second. The level, that's going to be tied in to the confidence interval or the prediction interval. And that's really, and then the NA action, you can either do NA omit, which is usually the thing to do. Okay? So, the object is your LM object. New data is a data frame. The important thing is your interval. So, where it has 0.95, that would be your 95% confidence interval. You could change it. Let's just say for argument, you wanted a 90% confidence level. It would be 0.90. Okay. Then the NA action, if you want to run it and you don't want any trouble from the NAs, you would put NA action equals NA dot omit. Okay? Good. So, what I'm going to do is create a little data frame. I'm just going to call it new 1. And I'm going to call it data.frame year equals 2011. Now notice, it has to have the same name as the x value here. If it doesn't, it won't run. Okay? So right now, I'm not going to do any intervals, just for laughs. I'm going to do predict. And if you go back in your notes, we had a pop.lm. We have new data equal to new 1. And that's all we need to do to get the estimated value. So that's your y hat when x is equal to, or in this case, year is equal to 2011. Okay? That's your future value. Now, you usually don't want just the future value. You need to have an interval about it. So there's two kind of intervals. One is a confidence interval, which you have done since time immemorial. And that's a sort of a mean interval. And the best way to explain this is, suppose you're shopping for a home and you go into a neighborhood and you want to look at the average price of a home. And you set up an interval for that. That is a confidence interval. Now, on the other hand, suppose you want to set up an interval for a specific house. That is called a prediction interval. That is 1 unit. Okay, the formula is slightly different, and we'll go through the exact formula, when I'm in class. And let me show you what these will look like. So here we have predict, pop.lm, new data equals new 1. So then I'm going to put interval equals new 1, and then my fault, interval equals confidence. Okay, so that's the one that's the mean, that's the average. So you notice you still get the same value here, the fitted value, and then you have your lower and your upper, just like in the old days in 3309 or 3311, whatever you took. Okay, no big deal. Now, suppose I wanted to have a prediction interval. I wanted 1 unit as opposed to a mean. So you're still going to have the same predicted value. Again, that's as it should be. But you notice how much wider the interval is? That's as it should be. Okay? Good. All right. Now, let's look at one that has a couple of different variables and see how that changes. Actually, it doesn't change very much. You just have more variables to put in. We're going to look at a data set called Ornstein, and it's actually after an author in a paper. So it has assets in millions of dollars, what industrial sector, what nation, the nation of control the company was from, and then the interlocking director and executive positions shared with other major firms. And this took place around 1970. Okay, it's old, but at least it gets you a feel for the data. So let's take a quick look. I always like to look at my data. Okay. All right. So I'm going to set up my linear model object, and in this particular case, the interlocks is a function of assets plus sector plus nation. And it comes from the data set Ornstein. Okay. Now let's look at the summary. Okay. So if you take a quick look at it, it doesn't look like the world's greatest um, model. But interestingly enough, if you look at the goodness of fit, the p-value for that is close to 0, even though the individual um, p-values are not the most stellar. Okay, so let's look at these. Here are your dummy variables, your factors. All right, so let's do some predicting. And just for laughs, I'm going to let assets equal 150,000. I'm going to let the sector be from the manufacturing, and I'm going to let the nation that the company comes from be Canada. So what's going to happen when I select sector to be manufacturing? All these guys are going to 0, right? When I select the nation of Canada, then all of those go to 0. So let's see what we can come up with. So I'll set up my new data frame. Now you don't have to put all of those in. Don't worry about that. You'll have assets equal, 150,000. You will have sector equal. Okay, now notice you have to put this in quotes, the man in quotes. Similarly, the nation, the can for Canada, also in quotes. Now we do predict, and we have orn.lm. The new data equals new 2. And let's do a confidence interval first. And let's see, confidence. Okay, so there's roughly 132 interlocks. And there's your interval. Let's do your prediction. Okay, see how the interval expands? Okay, so that's all you have to do your prediction. Pretty slick, huh? Hope you like that.